Assalamualaikum warahmatullahi wabarakatuh. Our group will present about our assignment of data analysis. My name is Muhammad Hoyumil Ismail. I will present about regression. It has 5 analyses, which is descriptive analysis, correlation analysis, model summary, ANOVA, and coefficients analysis. First, descriptive analysis. The mean of average collection for rental in this development is 791.48, while the standard deviation stated for rental is 51.568. This shows the highest standard deviation, the highest the volatility of a rental in the bell curve, and the more dispersed from the 0 point in the graph. Next, correlation analysis. The variable that positively influence the person correlation are corner types, lots, account types, gate types, and renovation done. The most significant renovation done with p-value is smaller than 0.10. The least significant booming status with p-value bigger than 0.10.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Izzati binti Syamsuddin. So today I will present about regression, which is model summary analysis. So basically, as you can see in the table, 67% of adjusted R-squared shows the variation of the rental, which is explained by the other predictors, consists of rental differences, corner type, lot booming status, and lot type, account type, gates, and renovation. According to this table in the slide, it has demonstrated that the output of the analysis of the ANOVA analysis, and whether there is a statistically important differences among the group means. So the value of the F, which is 6.901, attained a significant value with the 0.000. So the model is very significant because it has p-value less than 0.10. Therefore, there is a statistically significant differences between the regression model and also the outcome of the variable. On coefficient analysis, we are going to analyze standardized coefficient, which is beta, t-value, and also p-value. So based on our model, we conclude that N dot type has the best significance, whereas it has a positive related to rental, which is beta. It has 0.176. It also has the highest t-value compared to the other 4 variable, which is 1.419. And also has the smallest p-value, which is 0.174. But it is not significant influence to the rental in the development, but it's still the smallest value. Also, all the variables are not significant influence to the rental because they have p-value more than 0.10. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Afika binti Jamil. I will present about descriptive analysis. In order to perform statistical analysis, a descriptive analysis is the one of data analysis techniques. It gives people more understanding of the distribution of the result, allow to identify variables, making ready perform more statistical analysis and others. Descriptive analysis also can be used to summarize the data. If the data is categorical, frequency and cross-step procedures is the best procedure to be used, while scale level of data, descriptive is the best one. Firstly, the descriptive procedure will give the descriptive statistic for the variables. Descriptive is geared more towards scale data rather than nominal and ordinal data. And descriptive statistic also can be used for the level of measurement. Besides, the frequency procedure works more better with the categorical data than with scale data. It is because frequency will tell about how many times each value appears in the data analysis. Next is cross-step that is useful for generating the joint frequency between different variables and suit with the categorical data. According to the table above, it shows the overall result of data from the variable in form of descriptive statistic. In descriptive statistic, the minimum number of data for the lot is 4,448, with the maximum number of data that is 4,474, while it means is 4,461, and the standard deviation is 7.937, which is less predictable yet still increase the depression from the central tendency. Next is 750 is the minimum number of data for the renter with the maximum number of data that is 1,000. While it means is 791.48, and its standard deviation is 51.568. Besides, for the land, the minimum number of data is 153 with the maximum number of data that is 290, while it mean is 181.22. And for the standard deviation is 54.019. In this category of variables, it shows that the highest standard deviation is for the land. Other than that, we can see as shown in the table, there is no minimum number of data for the gate, but the minimum number of data for the gate type is 2, while the mean defined by the gate type is 0.63, and meanwhile on standard deviation by gates type 0.742, less votable for the average of the statistic data. Besides, the account type also does not have minimum number of data, but the maximum number of data for account type is 1, while the mean for account type is 0.56 and its standard deviation is 0.506. Indeed, the minimum and maximum number of data for renovation done is same with the account type, and the mean of renovation done is 0.26, where the standard deviation is 0.447. It's more volatile, but it's varying from average. Furthermore, Bumi status do not have minimum number of data. Its maximum number of data is also 1. It means it's 0.44, while its standard deviation is 0.506. Moreover, the minimum and maximums number of data for design type also same with the Bumi status. Next, we go to the frequency. Regarding to the table above, it shows the statistic of frequency for some variables such as gates type, account type, Bumi status, design type, end-load type, and corner type. First, frequency tables has been used to analyze the frequency for the gates type. As we can see, based on the table given, there are 4 types of gates, which is standard gate, decorated gate, and automatic gate. The frequency for the standard gate is 14 with 51.9%, valid percent, and cumulative percent. Next is for decorate gate. It record 9 of frequency with 33.3% and valid percent, while its cumulative percent is 85.2. The other type is automatic gate with 4 frequency, while it presents and valid percent is 14.8 with the 100% of cumulative. So the standard gate have the higher frequency. Meanwhile, another variable for the frequency table, which is the second frequency table in this slide, is the account type. There are 2 account types, which is standard accommodation and improved accommodation. The standard accommodations show its frequency with 12 with the same percent, valid percent, and cumulative percent, which is 44.4. Other than that, there is improved accommodation. The frequency for improved accommodation is 15 with 55.6% and valid percent, while the cumulative percent for improved accommodation is 100% of cumulative. This show improved accommodation is have the higher frequency other than standard accommodation. Moreover, another variable for the third frequency table is the Bumi status. There are only 2 Bumi status, which is Bumi lot and non-Bumi lot. For the Bumi lot, the frequency state is 15 with a 55.6% valid percent and cumulative percent, while for the non-Bumi lot, The frequency shown is 12 with the 44.4% and the valid percent, and accumulative percent is 100. Between the two Bumi status, Bumi lot have a higher frequency rather than non-Bumi. Furthermore, the for frequency table for design type, there are two types of design. The design type is basic design and modern design. The frequency for basic design is 13, while 8% valid percent and cumulative percent is the same, which is 48.1. For the modern design, the frequency record is 14, while the percent and valid percent is 51.9. For the cumulative percent for modern design is 100, and the higher frequencies is owned by the modern design. Refer to the next frequency table, which is fifth frequency table above. It shown that variable of n lot type. The variable of n lot type. There are two n lot type, which is non-intermediate and intermediate lot. The frequency for non-intermediate is 24, with 88.6% valid percent and cumulative percent. Meanwhile, the frequency state in the table for intermediate lot is 3. 8% and valid percent is 11.1, while the cumulative percent is 100. For the n lot type, the higher frequency goes to the non-intermediate lot. Besides, based on the last table of the frequency, it shows the two types of corner type. The type of corner is non-corner and corner lot. The non-corner show 24 as 8 frequency with 88.9%, valid percent and cumulative percent. At the above table, the corner lot state 3 as the frequency with 11.1% and a valid percent. For the corner lot, it records 100% of cumulative, and we can conclude that non-corner lot is the higher frequency for the corner type. Next, we go to the cross step. According to the table above, it shows the case processing summary for the cross step. In this study, gate type have been used to analyze the cross tabulation analysis between the gate type and other variables such as renovation done, Bumi status, and lot type, corner type, and intermediate. It shows the case processing summary with the percent of valid, missing, and total of the variables. The first cross tabulation table shows the relation of gate type for the renovation done. As we can see, the standard gate recorded is 10 with no renovation, while it recorded 4 with renovation, with a total of 14. Next, for the decorate gate, it states 6 with no renovation, while with renovation is 3, and the overall total is 9. Meanwhile, for the automatic gate, there is no gate renovation, while for it no renovation gate is 4. So the overall automatic gate renovation and no renovation is 4. The total of no renovation is 20 and with renovation is 7, and the total for all type of gate is 27. Secondly, the above cross tabulation table is the relation between gate type and Bumi status. Refer to the table shown. The standard gate recorded is 10 for Bumi lot, while it recorded 6 for non-Bumi with a total of 14. Other than that, for the decorate gate, it states 5 for Bumi lot, while for non-Bumi is 4, and the overall total is 9. In addition, for the automatic gate for Bumi lot is 2, and same for the non-Bumi, which also 2. By that, the overall automatic gate for Bumi lot and non-Bumi is 4. For the total of Bumi lot is 15, while for the non-Bumi is 12. And the total for all type of gate for Bumi status is 27. For the next cross tabulation table is a relation of gate type For the corner type, regarding to the table above, the standard gate record is 14 for non-corner, while there is no standard gate for corner lot, and the all total is 14. Moreover, for the decorate gate, it states 7 for non-corner, while for corner lot is 2, and the overall total is 9. For the automatic gate for non-corner is 3, and for non-corner lot is just 1. In this table, the overall automatic gate for non-corner and corner lot is 4. As for the total of non-corner is 24, while for corner lot is 3, and the total for all type gate for corner type is 27. Lastly, the cross-tabulation table above show the relation between gates type for the intermediate. The above table demonstrates 2 for the standard gate of non-intermediate, while for intermediate lot there is 12 state in the table, and the all total is 14. Indeed, for the decorate gate is state 2 for non-intermediate, while for the intermediate lot is 7, and the overall total is 9. Also, for the automatic gate, for non-intermediate and the intermediate, which is only 2, the value of the overall automatic gate for non-intermediate and intermediate lot is 4. And last but not least, for the total of non-intermediate is 6, while for intermediate lot is 21, and the total for all type of gate for intermediate is 27.
Assalamualaikum warahmatullahi wabarakatuh. My name is Husna Nadia binti Ahmad Sabri. So I will present the correlation analysis. What is correlation analysis? Correlation analysis is used to test relationship between quantitative variables or categorical variables. In other words, it's a measure of how things are related, which is correlation analysis also the study of how variables are correlated. The usage of correlation analysis depends on our data set and the objective of the study. Correlation analysis is used to quantify the degree to which two variables are related. Through the correlation analysis, we evaluate correlation coefficient that tells us how much one variable changes when the other one does. Correlation analysis also provides us with a linear relationship between two variables. So, in correlation analysis, usually we want to find out whether the variables are dependent to each other or not. But for this type of variables, we want to find out the variables which are not dependent to each other due to y equal a plus b s. So, after running the variables in the SPSS, in the table 4.1 above, this one, it shows that annual value AV and rental value has strong relationship, as it show 1 as it more than 0.8. So the data is considered not okay, as it does not show below 0.5. Next, when the output in table 4.1 is not considered as good, so the variable will be diminished, which I choose are rental, land, AV, and computed. So in the table 4.2, after modified the data, the output is still considered not good, as the intermediate and end lot still has strong relationship to each other or dependent, as it close to 1. So the data still need to be modified. In the table 4.3, the intermediate end lot and corner lot is assigned as position in the SPSS. So after run the data, the output is quite good compared to table 4.1 and table 4.2 as before. But there's a problem when the design type and build up has strong relationship, which is it close to 1. So the table 4.3 also need to improve or modify to make sure that the output data is good. So in the table 4.4, the output data is finally better or good compared to another output data, such as in the table 4.1, table 4.2, and table 4.3. This is due to the removal of design type so that the output data is mostly below than 0.5 as it consider a good.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aina Shazwani binti Mak Fauzi and I will present for the discriminant analysis. For introduction to this discriminant analysis, technique employed by the researcher to analyze research data when categorical criterion or dependent variable is defined as interval in nature. The term categorical variable means a number of categories for the dependent variable. For instance, the categorically dependent variable can include three brand names, which is computer A, computer B, and computer C. For the purpose to this discriminant analysis is to develop discriminatory functions that are nothing more than the linear blend of independent variables that perfectly distinguish between the categories of the dependent variable. It allows the researcher to examine whether the predicator variables are significantly different between the different groups. The exactness of the classification is also assessed. The number of categories that are held by the dependent variables is defined for the discriminatory analysis. For the table of group statistics shown for the non-intermediate lot, the unweight has been analyzed, which is 6 level, while the intermediate lot unweight is 21 level. Mean value for non-intermediate lot, which is higher than intermediate lot, and standard deviation a little bit larger from non-intermediate lot, which is 93.09493, and for intermediate lot is 32.33751 for rental variable. And for the table of test of equality of group means shows the significance of each variables was different for each predictable variable, which is non-ideal. And for the table pool within groups, matrices computed and rental was correlated, which is 0.997, and the strongest while rental difference variables and rental was negative 0.079, which is the lowest. For summary of canonical discriminant function, the table of eigenvalue shown the larger value eigenvalue, the more variance the function explain independent variables and the outcome variables. As we can see, the canonical correlation is 0.997, just quite high to calculate the effect size that we can square the canonical correlation value. And for the table of Wilks lambda shown that the predication models fit in this case, as we can see the predication model is statistically significant. And for the standardized canonical discriminant function coefficient table, shows us the relative importance of 5 predicators, and we can see the build-up was the best predicator, which is 0.675, then competitor is negative 0.1563, which is the worst predicator. And the structure matrix table is pull within groups correlation between discriminating variable and standardized canonical discriminant function variable order by absolute size of correlation within function. And this variable not used in the analysis. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Nurul Fatiha binti Muhammad Raizat. Now I'm going to present about dispersion analysis. Introduction. A measure of dispersion is a summary statistic that represents the amount of dispersion in a data set. While a measure of central tendency describes the typical value, measure of dispersion define how far away the data points tend to fall from the center. A low dispersion indicates that the data points tend to be clustered tightly around the center. High dispersion signifies that they tend to fall further away. The most common numerical measure of dispersion for a variable are the range, the variance, and the standard deviation. Function of measure of dispersion. The range is simply the largest number in data sets, subtract the smallest number, and it gives an idea of the spread of value or distance. With the range, the distance between the most extreme points can be quantified.
The variance indicates how close to or far from the mean in most of the cases for a particular variable. The variance is useful to have because it tells how much variability is in the data. Standard deviation is the square root of the variance. It is a standardized measure of dispersion that most frequently used, which allow to compare distribution of different variables. Purpose of measure of dispersion. The main purpose of measure of dispersion is to get as much as possible a true picture of the data. Dispersion indicates the spread or variability of the data in a distribution. In other words, dispersion is the amount of spread of data about the center of the distribution. It also to determine the reliability of an average and serve as a basis for a control of the variability, including to facilitate the use of other statistical measure. Dispersion analysis data. The data set is analyzed according to the level of measurement. Nominal and ordinal variables are analyzed by using median, mode, minimum, maximum, and range, while interval ratio are analyzed by using mean, median, mode, variance, standard deviation, minimum, maximum, and range. The table shows the statistic of nominal and ordinal variable of dispersion. Measure of dispersion can be determined by range. The largest the value of range, the more dispersed the cases are on the variable, and the smaller the value of range, the less dispersed the cases are on the variable, which will be more concentrate. From the table, we can conclude that the gate types has a range of 2, which indicates of automatic gates. The accommodation, which account type, has a range of 1, which is standard accommodation. The renovation done has a range of 1, which indicate for with renovation. The Bumiputra status has a range of 1, which is non-Bumiputra. The design type has a range of 1, which indicate for modern design. The corner type has a range of 1, which is corner lot. Then this table shows the statistic of interval or ratio variable of dispersion. Measure of dispersion also can be determined by standard deviation. If the data are widely dispersed, the central location is said to be less representative of the data as a whole. Based on the table, the value of data spread for land from the mean is 54.019. The value of spread data of rental from the mean is 51.568. The value of data spread of build up from the mean is 22.025. The value of data spread of annual value from the mean is 618.816. The value of data spread of computed from the mean is 51.40707. The value of data spread of rental difference from the mean is 0.506.